intelligence is just a combination, or like having a huge knowledge of stuff and being able to combine it well.
On the Experts Connect podcast, we have thought provoking conversations with top performing experts on topics that matter to you. With Experts Connect, you'll uncover fascinating facts and gain the necessary skills you'll need to improve all aspects of your life. You've been telling us a lot about the tools and the differences between classic machine learning and deep learning, but can you please provide us with a timeline of the evolution of machine learning?
I do. Yes, I do have a slide actually. Or maybe I will present again because I'm not too good with dates. I'll give you a slide here. Yeah, AI breakthroughs, right?
Yeah.
So I mean, I will not maybe not go through all of them, but just to be noted, as you can see, that the first date is 1956, right? So the first time actually the term artificial intelligence was used. And you can think of, if they use this term there, the idea is already much older, right? So it all started way before the 50s. And then it goes on. You can see, for example, here in the 80s, the first they made actually money with AI. And this, of course, then sparked like, oh, wait a second, you can make money with that. And then, of course, then you get a bit more funding here and there, and more people are interested in that. So that boosted the first AI wave, you could say. And yeah, and especially also with the birth of the internet, because I mean, yes, as we know, you need just data to work with. Even not at that point, of course, you didn't have access to too much data here over the internet, but that means like there was a second thing that needed to be happening to make the what we have today, right?
Yeah.
So that was actually a really important part. And the problem was actually here back in the 80s, we had the first so-called AI winter. So meaning that suddenly people realized, and this was in this case, I think there were two AI winters, I think one in the 70s, one in the 80s, if I'm not completely wrong. Probably people have to correct me here. I was not born then. But so the thing is, people first noticed like, okay, what can you solve actually with all these problems? I think in the 70s, I noticed, hey, you cannot the problems were solved were all like gimmick stuff, right? And then I was like, okay, it's nice, it's a fun idea, but you cannot solve real world problems with that. So and then suddenly funding started to decrease a lot. And so this is called the first AI winter. And then people, just a few researchers, just like they kept going because they had the idea that there's something to it. And then later on, just the computation power and the amount of data was missing. So again, then maybe they saw like, okay, we can solve more interesting things, but we don't have the actual capabilities to do it. So that was the second AI winter here.
Yeah.
And that's always stick in the heads of people, because I talked to a lot of also, let's say, older generations, and they actually had that in maybe the first studies back also in the 80s, like, yeah, I've done that, and that's just buzzwords, etc., right? It will die off again. And most likely they have that experience back in their memory as well, saying like, ah, this was already there, right? And it's died down. But I can assure you it will most likely not die down again. But just to have that as a reference, right? And I personally remember that was actually, I remember when Gary Kasparov was actually defeated by Deep Blue, and that was kind of the thing, that an algorithm was really well analyzing chess moves, and actually they had actually a huge library where, like, they went through this library and got the best moves, and that was actually like just showing the power of good algorithm here, right? And then continuing, first actually 2005, actually 2004, the DARPA challenge started with like, okay, we want autonomous driving. This is from the military. They said, okay, we want to have cars. They have to completely go autonomous, I think for 600 miles, 200 miles or something, through the desert. But in 2005, actually 1 year later, actually the first car, or the first cars, I think was several cars, made it actually the whole time, and completely autonomous. So autonomous driving is already there since 2005. Of course, I think they drove super slow. Maybe it was a desert with, I don't know, a couple of trees here and there. But generally, the idea was there, right? The idea was already born quite early.
Mm-hmm.
Yeah, Jeopardy. So in 2011, the Jeopardy victory also quite interesting. The Jeopardy, very interesting, because um, the first time that the computer would understand a question, that was important, because somebody would type in the question. It was not about searching not the same thing as 97, where they have a good algorithm to search for the right answer. But here's my more understanding a question, understanding the context, like what is the question really, and then finding the correct answer to that question. That was here the next step. Yeah, and then 2012. Yeah, computers learn to identify cats. I mean, and this is 2012. It's 8, 9 years ago. It's not that long ago. But this is like when we think of artificial intelligence, like this is cats, right? Cats and dogs. This is AI, and this is really for me. I feel it's quite recent actually. So, and even then comes Alexa. To be honest, I thought Alexa is not that old, but okay. But again, here this is again the novelty of actually understanding speech,
Yeah.
but also speech synthesization, so meaning to give an answer, but also then have the search heuristic to get that to a cloud to get that back. So the whole machine is actually quite impressive. But also, first of all, just to understand the question you are asking, and that's not that simple as we think. It's actually quite, because man, for you, us humans, it's very simple to understand language and directly to put it into context. But for a machine, this is a really difficult task. Maybe later we can talk about it a bit more.
Yeah.
Yeah, and in 2015, machines see better than humans. That's interesting because what they did there, they were just showing a machine and humans pictures, and you have to guess what it is, not to guess, just to say what it is. And 2015, the first time the machine had less errors than a human.
Mm.
Meaning, of course, I mean, in this it was a controlled environment, just somebody sitting in a room just watching at pictures, etc., and maybe he dozed off at some point or something, but that shows exactly that. So the machine, first of all, doesn't doze off, and it was at least as good as a human, but the failure rate was actually better than for a human, for the, I think, for the top 5 accuracy. um so yeah, impressive. And this is 2015, and you can see, I mean, just the time, look at the timeline, how fast this is progressing, right? From here, from the first time cats to they see better than humans. I mean, this is just 3 years, right? And you can just imagine how this is going on. Yeah, and then AlphaGo. That was an interesting story because I talked to one of the professors who was closely entangled with the team there, or at least he was in over there in it was in Korea, I think, right? And apparently in Korea, it's a huge deal, right? Alpha, this game, which is a bit more complicated than chess. And when they had this machine, which actually in this case could not have a database of games, because there's so many moves in Go that you can't just go through a library and find the best move, but you have to just learn the game, to learn the rules, right? And this was an absolute novelty here. But the people said like, the machine will never win because they play it against the best player here we have in Korea, so he has no chance at all. And then AlphaGo actually made the first move, and he made the loser move. And people say like, "Whoa, what a stupid machine! Like, wow, no chance at all." And then AlphaGo won, and apparently in Korea, people said, "Okay, this is the end of the world. Now it's done." So we're it's over. So yeah, that was a fun anecdote when he told that. But yeah, here the idea is to learn a system, to understand a system, like a rule-based system, just of course not in a co-world environment, but in a really restricted area, but to understand the rules and to learn it by itself, and to teach by playing over again. You just to get to grasp a game and to grasp the rule, and then to perfectionize the rules and play better than the best player who has trained for, I don't know, since childhood probably, right? And it
Yeah.
was a huge step here. Yeah, then okay, self-driving cars. I mean, we see that more and more. Yeah, and then in 2019, I put something together. So Rubik cube, flipping the Rubik cube, that was quite nice. But then also fun thing. So if you're on the field, you might think like, okay, back in that, this was actually relatively novel to put randomness and noise into the data set you train to make the system much more robust. And it was really interesting because that actually made a huge step actually in the performance of the algorithm. Beforehand, you said like, no, your data set has to be perfect. If you go cats and dogs, you have to perfectly separate your cats and dogs beforehand and label them correctly. Otherwise, the algorithm will be performing not well or has errors in itself. But then they notes like, just putting some slight errors in there makes it actually more robust. It's quite interesting.
Yeah.
And then here, winning against 6 players, that was also again. So it's going on and on, and Yeah, it's this was 2020. I don't even have 2021 on there. Yeah, it's getting more and more crazy. And to be honest, I'm in the field quite a while now, but I have to keep up. I have to read every day to keep up just with the pace. It's unbelievable. Yeah, to be honest. um, yeah, but I'm looking forward to the next 50 years or so.
Yes,
Yeah, but
where?
I think yeah.
No,
Sorry, no,
please finish.
no, I just wanted to say, yeah, it's a good, nice start to be here. But then let's see, next when we talk next year, this probably will be much grown. Yeah.
More extensive, yeah. And where are you finding these insights, these impressive insights? Where do you find this information?
Oh, it's called the internet. No, but of course, and then the sorry, no, but yeah, it's of course a lot of stories. Of course, I collected over the years. You hear it here and there, and I'm interested in that field for a long time now. So you get that, and yeah, of course, for preparing for a workshop or something, you of course you dig through the stories again. It's like, oh, what was it again? How did Deep Blue again defend Casper? What was the insight here? So yeah, you could just put bits and pieces together. It's actually I have not seen one. Probably there are proper sites out there who list all the achievements in AI, but yeah, I hadn't found them. I need an algorithm for that, maybe. Yeah.
Okay, so I meant if you were subscribed to some mailing list, AI mailing list, those kind of stuff.
Most likely, yeah. But the thing is, also, there's a lot out there, right? And in German we say you have to Spreu vom Weizen. I don't know how to say it, like the good from the bad. So I most likely there's also. I mean, I have some mailing lists, but they're just spamming my email account, and at the end I don't read them because it's too much. So you have to find your sources, one or two. I mean, I also have colleagues I just talk to, and then it's like, hey, have you heard this new story? And they're, oh, what? And then I dig into that, and so yeah, it's you just have to find your source you're most comfortable with, which reading material you like to read as well. Also, the style of writing. Do you
Yeah,
like a lot of pictures? Do you like it super scientific, or do you like it more like, oh, just a bit more easy? It depends on you yourself. Yeah.
yeah. Okay, thank you, Jan. And our next question. So, what are the main fields of AI? Or what are the
Yeah.
main fields where AI is used?
Yeah. I would say yeah. They are for again. I will go back to my slides because it's most best explained here with the slides. It's also again from the workshop. Yeah, you can see it right. So you can see there are four. I would say there are four main topics, and that will be image processing is maybe the most known. Why is it most known? Because I mean, of course, we humans we see and we can directly identify like, oh yeah, this is a problem I could solve with just looking at it, right? And so, wouldn't it be nice to have an algorithm to solve this? And if you look a bit closer, we see three different types here. That will be object classification, object recognition, and then image segmentation. And it's just like it's kind of a cascade. We have like first the object classification is just saying this image is a dog or this image is a cat.
Yeah,
And you could, for example, use it for quality control. If I said here, yeah, even like, okay, I have screws and I train my algorithm like, okay, this is a bad screw and this is a good screw. And so I could just show them one screw after another and say good, bad, etc. Right? So that will be one thing, for example, to use it. And the other thing is object recognition, meaning you recognize multiple, if not all, objects on your image and said, okay, here's a dog and there's a cat, and then you have these bounding boxes. Maybe you know that from if you have to do facial recognition, right? They make a nice green square around your face, and this is actually object detection. And then you can identify several objects actually there. And then good thing would be for counting, for example, or actually you can use it for numerous just think of something probably you can use it for that. And yeah, it also man interesting is also like area of interest analysis. So what you would like to do, so if you want to identify something closer but those, the first input image maybe is not that high resolution, you can say like, okay, I see here it detected something I find interesting, and now I can zoom in into that area and get a more high resolution image of that, for example, to minimize bandwidth or just calculation power exactly.
yeah,
So that would be an idea. And then you have segmentation, the last part here, and that is just going pixel by pixel, and more or less doesn't have to be pixel by pixel, but like objects are really get the shape of the object, not just a bounding box, and you can dissect the whole image and say exactly what is what. And that is of course used, for example, by in autonomous driving, most likely. Actually, I don't know because I don't work at Tesla, but I'm sure, for example, they use it there just to dissect the whole scenery, what's there, like pixel exactly, and say like, okay, there's a human, you have to brake, or this is a ball that most likely there's a child behind the ball, or something like that. So you can get much more in detail here. Yeah, and then on the other part, you have natural language processing. It's actually one of the other main fields at the time,
Yeah.
and yeah, even you don't hear, or let's see, if you Google stuff, if you Google about AI, mostly you will see image processing stuff, right? All the demos are signal processing demos. But actually, one of the strongest research fields next to image processing is actually natural language processing. And here we're like, of course, speech and text recognition. That is one thing, of course. But then very interesting also speech synthesizing speech. Sorry, English. Um, so meaning creating speech from noise, more or less, right? And it's really interesting. So I will not show it now, but okay, listeners, please go to the website wavenet.com. Wavenet is actually from Google. It's actually already a bit older now, but I think I found it really interesting. And you can listen into to some examples. How it sounds, and first of all, you notice, okay, it sounds just perfectly. How the speech is really natural, but more interesting is a bit further down the side, you can see how it's actually evolving. So you can see that the first is just like a bit of blabbering, and it's actually, if you listen, if you wouldn't focus on what is said, you think like, oh yeah, somebody's speaking probably English or something. But then if you listen to it, like, no, no, these are actually not words. So there's just made up words. But you can see how like the language is just formed. So it's kind of like a baby's learning. First of all, making the same sounds, and suddenly one word comes to another, and suddenly you have a sentence. And so it's very similar to how they created in WaveNet. So, I like the approach quite a lot. So yeah, but so speech synthesization, Alexa, for example, when they speak to you, right, there's a speech synthesization. um, so creating speech out of nothing, so you don't have to have a table saying, okay, take this word and put that word together and that word and then just play, but creating that speech so that you can be much more valuable, and you have much smaller, you need a much smaller database because you just need your model instead of a huge audio file base where you just put that together. Yeah, and then you have, of course, other things like sentiment analysis, or I mean, like, okay, how is somebody feeling? You can extract that actually from speech analysis as well, and much more things as well. It's really interesting. Um, yeah, look into that. It's a fantastic topic on its own. And then yeah, translation, of course. The bubblefish, don't panic. Like I need the bubblefish in my ear. That would be. I wouldn't hesitate with so many words now. And and then another thing is time series analysis. I actually for medical data, for example, it's quite interesting, or machine learning, machinery data, because that just means looking at data which comes with a timeline, let's say, right? Because before, like the image processing, even if you think of video, video is also like something with time, but it's actually not the case. It's like each image in a video is analyzed separately, so it's just image by image. But the time series analysis means that the time itself is also important. Again, when we work with preterm infant sleep analysis, like a sleep is a time pattern, right? So you have phases, and then it's change over time. So you have to think of how does it change over time. It's slightly different types of algorithms, and of course you can use that for predictive maintenance and this kind of stuff. These are all time series analysis patterns, and of course you can also intermix all of those four together, right? But I would say kind of this is kind of the four main topics. Maybe I forgot one. I hope not. Please email me. um Sorry. And then you have the last one is data generation. Yeah, speech synthesization is of course also data generation, but I'm talking here like of the image video generation, like gun networks, deep fakes, style transfer. Maybe you have heard of those. Really interesting. A lot of people think they're gimmicks, but actually it's not only gimmicky. Maybe you come a bit later to that part again. Also, it has some negative side effects as well. And but also, but in a positive way, you can create, for example, to create measurement data, because there are some classic methods how you can create measurement data if you don't have enough, like next neighbor algorithms, etc. Um, but this one is slightly different because you create completely new data from the knowledge of how the data is built up. It's also quite interesting topic here. But yeah, I would say these are the four main fields of AI. And if I forgot one again, please don't stall me. Just send me an email and I will learn something. But yeah, if I didn't, so I think these are the main four areas, which of course can be interchanged and mixed together, etc. Really interesting. But yeah, I would say so. That's that's the main parts.
Very useful information, Jan. Thank you so much.
Welcome.
Yes, so let's move on. So, Jan, there is intelligence in the term artificial intelligence. Is artificial intelligence really intelligent?
That's a good point. That's that because I actually had a lot of discussion with my brother-in-law. If you, hi Paul, if you listen in, it's interesting because yeah, because I, to be honest, back in the time, a couple of years back, I said like, yes, it's intelligent, but maybe I'll start different, because when I worked at Philips Research, I I had just brilliant minds around me. To be honest, I remember. So when I wrote my first patent, you mostly don't write patents on by your own, especially if you're a beginner. So I had a colleague who helped me out with an idea I had, and it was actually accepted. So thanks. That, and it was actually Jos Kalman. So shout out to him. And the thing is, Jos Kalman actually at some point stand next to me at the coffee machine and said, "Hey Jan, do you know? By the way, I'm one of the inventor of the CD." Dear Lord. Oh my goodness. So those kind of people you had around, right? So, and if you had an idea, you just you call in a meeting. You had like five brilliant people sitting there, everybody an expert in their fields, and you say like, "Hey, I have this problem. What do you think?" And you could be sure there would be a solution at the end of the day, mostly at the end of the meeting, actually. So. So I thought actually, what is actually intelligence, right? Because you would say all these people are highly intelligent, but you could also say what they really did. They had a lot of experience. Maybe they had also a high IQ and could remember things good, or depending. It depends from person to person. But especially, they were interested in a field. They knew a lot about that field, and they had the ability to combine stuff. So if I would say something from my field, it was like, oh, this is a good idea. By the way, I have another thing. If you combine this two, that should work, right? And so you could say intelligence is just a combination, or like having a huge knowledge of stuff and being able to combine it well. And if you just go this direction, and this was my idea a couple years back, I would say yes, sure. And then machine is of course also intelligent at some point, but maybe now the machines are not yet super highly intelligent, but they do stuff which is you could deem intelligence. I mean, if I look at my kids, right? I mean, I'm happy if he can hold a spoon. He wouldn't say he's intelligent, but on the other hand, to say it's an intelligent being, right? So he can hold a spoon and he feeds himself at some point. So you can say if an algorithm does the same, you can already call it intelligent. But now comes another point. So because my other brother-in-law actually he supported his brother, and he gave me actually a very good point, and I think that changed the topic quite drastically, because and I have to say I'm not an expert in neurobiology and chemistry and this kind of stuff. So I try to recreate what he told me, and probably I'll fail a bit, but be forgiven, please. Um, so the thing is that apparently we have something in our brain is called like microtubules, and it's just something in the brain which apparently is there for the consciousness of a person. So they noticed during an operation they would use benzol rings to I think to prevent them from decaying, to prevent the decay of this microtubule. And maybe this is completely wrong, but this is the general idea I got from that. And of course, if you are in an operation, you are not conscious. Yeah, right. This is a point like was used to shut off consciousness. And what they then noticed is that this pattern here, it showed while decaying, showed sign of a quantum state, right? And that suddenly creates a completely new dimension, right? If we have something, if we have a connector in our brain which connects us humans to a quantum dimension, let's call it, right? I mean, you can just think of what could happen there. Do we have a link there? Are we interconnected over this quantum dimension? I don't know. Or do we get information? Do we send information? I don't know. We don't know what part that plays, but I would say it plays definitely a significant role in us being humans, right? And also then maybe, yes, a system can be intelligent, but it's this like maybe the human spark, like the oh my goodness, I have the horika, I have the idea, right? Maybe that is missing in the machine and will forever miss in the machine, or I will not say forever because yeah, but let's see for the next foreseeable future, it will not be integrated in the machine. I think this is maybe the huge difference. So a machine can become very intelligent, but it will most likely not get this human thing of being aware, getting consciousness, and overthrow the human race. Maybe it might overthrow human race, but not because it's conscious. So yeah, so I think this is the main difference here. So yeah, I would say they come really close in being intelligence, even also the learning process, which I described, for example, for and with the WaveNet, right? How they learn, how things are formed. It's very similar actually to a toddler. Whenever look at my babies, I kind of see an AI at work, kind of, right?
Look at mine too.
Yeah, right. It's amazing. So sometimes I think I recognize a summer from Cody. Right? What is happening here? But of course, I think at the end, like the spark, the little bit extra,
Yeah.
that will always be missing. And of course, just from the computation power, we are still very far away from reaching human brain capacity. So that is just one part. But even if we at one point reach brain capacity just with calculation power, um, yeah, time will tell if we have the spark or not.
Yeah.
Yeah, but
I agree. Time will tell because back in, I think, 2006, when I was doing undergrad, we had this same question, and we all argued that machines do not have that level of consciousness that humans have. But some of the predictions that we made back then are actually being unfolded now in AI. So let's see what happens in the future.
yeah, exactly. Yeah, I'm really, I'm keen,
Yeah.
afraid and keen. Yeah.